Hello, Math Dog here. This video is on why slope is defined as it is. This could be a grade 7 all the way up to Algebra 1 video. Please do not share reproduce this without asking me, the Math Dog, first. So first of all, absolute value is the positive distance that a number is from 0 on a number line. So I have two numbers marked off on this number line. There's 0 right here. So the absolute value of -5 is defined to be 5 because -5 is 5 units from 0, and it is the positive. We define it as the positive distance. Then 4, absolute value of 4 is 4 because 4 is 4 units from 0. So we say though that the absolute value of -5 is greater than the absolute value of 4 because 5 is greater than 4. Remember the inequality sign, think of it as a Pac-Man. It opens up to the larger number. So we could reverse that Pac-Man sign or the inequality sign, but still it opens up to the larger number. So we've talked about this in a previous video, and before you actually get in this video you should watch the one on slope that I've done, the introduction to slope. So the way we measure slope again is it's the rise to run on a line. So it is the vertical change over the horizontal change. We can draw a right triangle under the line to see that. I usually call it delta y over delta x, where delta means change in. So it's the vertical change, the change in y, change in the y-axis over the change in the x-axis. So again, reviewing, change in y over change in x is the same as delta y over delta x, which is the same as rise to run, which is change in vertical over change in horizontal. So we want our definition of slope to be such that steeper lines will have a larger absolute value assigned to their slope than less steep lines. So line A, I hope you can see from previous video, is a positive slope because as you go from left to right it's increasing. Line B also though has a positive slope. It also increases as you go from left to right. However, line A rises faster than line B. Okay, so it should have a larger number associated with it. So let's calculate the slope of both a correct way, I should say. So I'm going to draw a right triangle under line A. Notice that for every one unit change in the horizontal, it's two vertical changes, 2 vertical unit changes. So the slope is 2 to 1 or 2. I believe it is 2 to 1. So for line B, notice to go from here to here, I have to travel 2 units horizontally and 1 unit vertically. So the slope of B is 1/2. And that's what I want. I want slope of A to be greater than the slope of B. So absolute value of slope A is 2, which is 2. Absolute value of slope B is the absolute value of 1/2, which is 1/2. Therefore, slope A, the slope of line A, is greater than the slope of line B. Okay, so now we're going to incorrectly calculate the slopes of lines A and B. And this is a common mistake that new students make. So again, I'll do the same thing here. That's a horizontal change of 1, vertical change of 2. This is a horizontal change of 2, vertical change of 1/2. But students often get the x and y reversed. So what they'll do is they'll take the change in x over change in y, which in this case would be 1/2. And this case would be, if they get it backwards, would be 2 over 1. But that's not right. Just to let you know that. So again, we want the steeper line to have the number with the larger absolute value as its slope, and that should actually be a statement, not a question. Did this occur when we took delta x over delta y? No, it didn't, because we're getting line B to have a greater slope than line A. So no. So this is a common mistake that students make when they first start working with slope. In this second example here, as we move from left to right, you can see line C drops faster than line D. We want line C to have a steeper slope than line D. So to calculate the slope of them correctly, we will draw a right triangle under each line. So line C, I'll use these 2 points. So to go from here to here, I'm dropping down 2 and over 1, so my slope is -2 over 1. For line D, if I drop down 1, then to get to this other point I go over 1, so that's -1 over 1. So while -2 on a number line is less than -1 because it's to the left, line C, the absolute value of -2 is larger than the absolute value of -1. So we say that we want slope C to have a larger slope, or line C to have a larger slope than line D. So we say slopes of line C is steeper than the slope of line D, even though the actual slope, -2, is considered less than -1. We say that line C is steeper than line D. -2, it is true, is less than -1. However, the absolute value of -2 is greater than the absolute value of -1 because 2 is greater than 1, and this is what we use to state that line C is steeper than line D. Again, so now we'll incorrectly calculate these slopes. So for C, again, that's a drop of -2 and 1 to the right. So that, but if I calculate it using the change in X over change in Y, I get -1/2, which is wrong. This is a change in 1 down, 1 over. So that's using, it's going to be the same in this case. You're not going to see the difference. So this is -1/2. This is -1. So according to this, line D has a steeper slope than line C, but that's not what we want. So what we want to do is we want to take change in Y over change in X. Here we took change in X over change in Y, which is wrong. Okay, so that is a common mistake that students make when they first start working with slope. So in conclusion, to calculate slope correctly, you must, absolutely must, take the vertical change divided by, that should say the horizontal change. That's a misprint. So here are 2 lines. So I want to draw a right triangle below. I could draw one above. I could go this way also. This would be a negative divided by negative, which is a positive, or I go positive divided by positive. So this is a positively sloped line. In this case, if I start here, go to here, I'm going down negative and over to the right positive. That gives me a negative slope. Or I could start here and go positive up, but then I have to go negative horizontal, so positive divided by negative is negative. So this is a negative slope, this is a positive slope. That is how you calculate slope. It is not delta y over, it is not delta x over delta y, it is delta y over delta x. So no, you do not do it this way. If you do, you're going to be all messed up.